In the vast silence of space, a storm is forming, not of rain or thunder, but of invisible particles racing from the sun at near light speed. They twist magnetic fields, blind satellites, and could one day bring Earth's power grids to their knees. For years, we've seen only shadows of these solar eruptions, but now NASA is doing something no one's ever done before, launching a mission to capture them in motion, in 3D from every angle. This is how we prepare for the next solar storm. This is Punch. The sun may look peaceful from Earth, but in space, it's anything but calm. Surrounding the sun is a blistering layer of plasma, the corona, where temperatures reach over 1,000,000 degrees. From this layer, the sun unleashes a constant stream of particles, the solar wind. These aren't beams of light. They're real matter, electrons, protons, racing through space at hundreds of kilometers per second. Most of the time, Earth's magnetic field protects us. It bends the solar wind around the planet, forming a kind of invisible shield. But sometimes, that wind intensifies. During powerful eruptions, called coronal mass ejections, the sun launches giant clouds of plasma directly into the solar system. When those clouds hit Earth, they can disrupt satellites, damage communication systems, and even cripple power grids on the ground. These storms are fast, violent, unpredictable, and for decades, we've tried to study them using limited tools, old satellites, and incomplete models. But we've never been able to truly see the full picture, not in real time, not in motion, not in 3D. That's what NASA's about to change. NASA's Punch mission is about to show us the invisible. For the first time, we'll be able to watch the solar wind in motion, not just as numbers on a graph, but as a moving structure flowing through the solar system. Punch stands for polarimeter to unify the corona and heliosphere, and it's doing something no mission has done before. 4 identical satellites flying in formation will act like one massive camera, capturing detailed images of coronal mass ejections and solar wind as they leave the sun and expand through space. These spacecraft will observe the transition from the solar corona into the heliosphere, creating a full map of space weather in action. Their data will help scientists understand how solar storms evolve, how they impact Earth, and how we can better predict and prepare for them in the future. The Punch mission represents a groundbreaking step forward in space weather forecasting. By observing solar wind and CME dynamics in real time, it will close a long-standing gap in our understanding of how energy moves through space. This isn't just about science. It's about protecting the technology we rely on every day. We know the solar wind comes from the sun, but we still don't know how it forms or where it truly begins. Somewhere between the burning edge of the corona and the darkness of space, magnetic structures swirl, twist, and break, shaping the wind before it escapes. These streams aren't random. They follow hidden patterns, too faint, too fast, and too complex to see with our current tools. Until now, with 4 synchronized satellites, Punch will capture those structures in motion every 5 minutes, in real time, in 3D. For the first time, we'll see how turbulence grows, how plasma behaves as it expands outward, how tiny changes near the sun create massive storms millions of kilometers away. Scientists believe this data will reveal the long-missing link between the corona and the solar wind. It's not just about watching the sun. It's about decoding the system that controls everything from satellite health to solar storms to deep space travel. And once we see the full picture, we'll never look at space the same way again. The sun powers our solar system. It shapes our skies, our satellites, even our future. And now, we're finally learning how it works. Because with Punch, we're not just watching the stars, we're understanding them.